This exercise is asking which of the following numbers are rational numbers and which are irrational numbers. Within this video, I'm going to concentrate on what we mean by rational numbers. And the reason this exercise is appearing in the playlist on surds is because in order to understand surds, we need to know what a rational number is and also what an irrational number is, as this information will certainly help us in understanding surds and why they are a good idea in mathematics. The numbers upon which we need to make the decision whether they're rational or irrational are coming into view now. We will start off by considering what we mean by rational numbers. A rational number can be written as a fraction. That's one integer divided by another integer. Let's look at an example. Here we can see we have 7 over 5. Now 7 is the numerator and 5 is the denominator. Now does this meet the requirement shown above? Well, the answer is yes, because 7 is an integer and 5 is an integer. So this is an example of a rational number. What about 3 over 4? 3 is the numerator, 4 is the denominator. Is this an example of a rational number? Well, the answer is yes. There's a 3 on the top, which is an integer, and there's a 4 on the bottom, which is an integer. So there's an integer on the top and on the bottom. The 4 is dividing into the 3. What about this number, 3/5? Well, again, the answer is yes, it is rational, because there is an integer on the top and the bottom, and in this case, 5 is dividing into the 3. Another example is the 2/3. This is also a rational number. As we can see, we've got 2 on the top, 3 on the bottom, and this 3 is dividing into the 2. And the 2 and the 3 are both integers. Let's consider the 4 rational numbers in front of you that are shown in their fractional form, and let's have a look at them in their decimal form. So I'll position them appropriately. I'll now go to the 7 over the 5, and that is equal to 1.4. So 1.4 is an example of a rational number. It is the decimal form of 7/5. 3 over 5, well, that is equal to 0.6, and 0.6 is a rational number. It's rational because I can write it as a fraction. In other words, I can convert this back to this if I so wished. Look at 3/4. Well, that is equal to 0.75, and 0.75 is a rational number because I can express this as 3/4 if I so wish. If I look at 2/3, well, that is equal to 0.6666, and these 3 dots means you carry on adding 6s. The more 6s you add, the closer to 2/3 you get. But the point is, this is nevertheless a rational number. Now, what I'm going to do, I'm going to home in on the 2/3. And we can see 2 over 3 is 0.6666 and the 3 dots. Now, this is referred to as a recurring decimal form. It means the 6s will carry on forever. What about another way in which we can represent this? Well, the answer is, you can see here, I've added more 6s, and there's 3 dots there to say I can carry on adding 6s. Now, these look strange. So you may think, well, these are irrational. No, they're rational, because this can be written as 2/3 and this can be written as 2/3. But the fact that both of these are recurring is another way in which we can identify whether the decimal form is a rational number. Let's consider 2/3 equals 0.6666. We've got the 3 dots. Now, frankly, there is a better way to write this down, and it is shown here. What you do, you write 0.6 and you put a little dot here, which means that you can carry on adding 6s. This dot tells us that the number below is recurring, so you can keep on adding 6s in this position. What about 1/3? Well, 1/3 is 0.3333, and then you've got the three dots, and we can write that as shown here, 0.3, and you can see the little dot, which tells us that it is recurring. Now we can see a rational number can be written as a fraction, one integer divided by another. But we've also now seen that we can write rational numbers in a decimal form. And it's therefore important that we extend our understanding of rational numbers by actually saying the decimal form of a rational number is either a terminating or a recurring decimal. Now I've covered recurring decimals here, but an example of a terminating decimal would be 0.75, which we should know is 3/4. Terminating because there are no more digits after the 5. It's 0.75. Terminates there, no more digits. Whereas we see with a recurring decimal, the digits go on forever. So we can enhance our description of a rational number as shown on this slide. A rational number can be written as a fraction, one integer divided by another. The decimal form of a rational number is either a terminating or a recurring decimal. So all of the numbers appearing now are all examples of rational numbers. Take 7/5, rational, both integers. Take this, it's 7.666. We can see that this is a recurring decimal part. Therefore, we know the overall thing is rational. This 0.3, well, we know the 3 goes on forever because of this dot. Therefore, this is recurring. So this is also a rational number. This is a whole number. Is it a rational number? And the answer is yes, it is, because you can write that as a fraction quite easily. What about this one here, 21.625? Well, we can see the 0.625 is terminating. There are no digits after the 5. Minus 19, that's rational, because you can easily write that as a fraction. 38 divided by 2, for example, would give you 19, and you just stick a minus in front to give you back the minus 19. This here, well, that's an example of a rational number, because we can see we got 3 and 3/5. And if you convert that to a decimal form, it would be 3.6. So all of the numbers in front of you are rational numbers. Let's home in on 2 of the examples. And if we look at this one here, we can see it's a recurring decimal. 7.666 and the 3 dots, meaning the 6's go on forever. And the fact that we've got a recurring decimal here tells us it is a rational number. What about this one here? Well, that's got a terminating decimal. It's 0.625. There are no more figures after the 5. So this will tell us that it's a rational number. So we can tell a number is rational if you have an integer being divided by another integer, or, as in the 2 examples shown here, you've got a recurring decimal or a terminating decimal. They, when it's in its decimal form, will tell you that you have got a rational number. Returning to the exercise we saw at the beginning of the video, and to remind you what it said, which of the following numbers are rational numbers and which are irrational numbers? Now we now have enough information to be able to identify the rational numbers, but I haven't yet explained what we mean by an irrational number. And I'm going to do that in the next video when we will complete the answer to this exercise. But every number you see in front of you is a rational number apart from this one, which is the square root of 2. And we'll explain why this is an irrational number in the next video in the playlist.